In 2023, the global average surface temperature exceeded 1.5 degrees Celsius, above pre-industrial levels for the first time in recorded history. Not for a decade, not for a year, for a single day. June 17, 2023, then it happened again and again. And by 2025, climate scientists were no longer debating whether 1.5 degrees would be breached as an annual average. They were debating what comes after. The emissions trajectories that would keep warming below 2 degrees Celsius by 2100 require a speed of decarbonization that has never been achieved by any economy in history, and that virtually no credible analysis suggests is currently on track. So in the quieter corners of climate science, in the departments that don't hold press conferences, that publish in journals most people never read, that receive funding through channels that are deliberately kept at arm's length from political controversy, a different conversation has been happening. Not about how to stop emitting, about how to block the sun. In June 1991, Mount Pinatubo in the Philippines erupted with a force equivalent to 100 million tons of TNT. It injected approximately 20 million tons of sulfur dioxide into the stratosphere. Those particles spread around the planet within months, forming a reflective aerosol layer that bounced a fraction of incoming solar radiation back into space. The result? Global average temperatures dropped by approximately 0.5 degrees Celsius for nearly 2 years. One volcano. 18 months of measurable planetary cooling, half a degree. The question that a small group of scientists, funded in part by Bill Gates, have been asking quietly for the last decade is straightforward. If a volcano can accidentally cool the planet by half a degree for 2 years, what happens if we do it on purpose? And what role has artificial intelligence played in taking that idea from a thought experiment to a funded, technically viable, actively controversial real-world proposal? Stratospheric aerosol injection, the technical name for what people are calling blocking the sun, is not a new idea. It has been proposed in scientific literature since the 1970s. Researchers have known for decades that reflective particles in the stratosphere reduce incoming solar radiation. The reason it remained a theoretical proposal for 50 years, rather than becoming a serious policy option, is attribution. Injecting reflective aerosols into the stratosphere at the scale needed to produce meaningful cooling, scientists estimate between 1 million and 5 million tons of sulfur dioxide equivalent per year, would create atmospheric effects that propagate around the entire planet, cooling over some regions, altered monsoon patterns in others, changes to the ozone layer, shifts in agricultural rainfall distribution that would benefit some countries and devastate others. Modeling all of those second and third order effects simultaneously at the resolution needed to make responsible decisions about deployment requires a level of atmospheric computation that simply did not exist before 2020. Between 2021 and 2024, AI-powered climate models achieved something that decades of traditional computational modeling could not: the ability to simulate stratospheric aerosol injection scenarios at regional resolution, not just global averages, fast enough to run thousands of variations and identify the injection strategies that minimize harmful regional side effects while maximizing global cooling benefit. This is what the Gates-funded SCOPEX program at Harvard was waiting for. Not the engineering. The engineering of dispersing particles in the stratosphere is well understood. High-altitude aircraft already exist that can do it. What was missing was the ability to answer the question that every government and every affected population has the right to ask before anyone injects anything into the shared planetary atmosphere. What happens to us specifically? AI climate modeling can now answer that question, imperfectly, with uncertainty ranges that remain wide, but with enough resolution to have a real scientific conversation about deployment scenarios rather than just theoretical possibilities. That shift, from theoretical to technically plannable, is what moved stratospheric aerosol injection from the fringe of climate science to the center of the most heated debate in the field. And it happened almost entirely in the last 4 years. Here is where this story stops being about science and starts being about something that has no good answer. Let's trace the chain. Effect 1. The termination shock. Problem. Stratospheric aerosol injection does not fix the climate. It masks the warming. The carbon dioxide causing the warming remains in the atmosphere. The heat that the aerosol layer is reflecting away is still being generated by that CO2. The aerosols themselves fall out of the stratosphere within 1 to 2 years and must be continuously replenished. This creates what climate scientists call termination shock. If a stratospheric injection program runs for 20 years, long enough for the world to become dependent on it for agricultural planning, water management, and infrastructure design, and then stops for any reason, funding failure, political collapse, war, or simple disagreement between the nations running it, all of the masked warming returns, not over decades as it accumulated, over years, possibly over months. The faster the rebound, the less time ecosystems, agriculture, and human infrastructure have to adapt. Scientists who study termination shock describe it using a specific phrase that appears in multiple peer-reviewed papers on the subject. They call it potentially catastrophic. This is why scientists who support research into stratospheric aerosol injection, including researchers at the Gates-funded SCOPEX program, are also among its most vocal advocates for extreme caution before deployment. They know what the exit looks like, and there may not be one. Effect 2. Who controls the thermostat? The second problem is governance, and it is, arguably, harder than the atmospheric science. Stratospheric aerosol injection at the scale needed to produce meaningful global cooling would alter precipitation patterns in ways that benefit some regions and harm others. The models, even the AI-enhanced ones, cannot eliminate this regional asymmetry. They can minimize it. They cannot remove it. Which means that whoever controls the injection program controls the global thermostat, and in doing so, makes decisions about rainfall, agriculture, and water supply for every country on Earth, without those countries necessarily having agreed to or even been consulted about the intervention. There is currently no international framework for governing stratospheric aerosol injection, no treaty, no regulatory body, no agreed protocol for who gets to decide whether it happens, at what scale, for how long, and under what termination conditions. A single wealthy nation, or a single wealthy individual, could theoretically initiate a stratospheric injection program unilaterally. The technology is not complex. The materials are not exotic. High-altitude aircraft that could do the job already exist. The Gates funding of SCOPEX is not a plan to do this unilaterally. The research program is explicitly focused on understanding the science before any deployment decisions are made. But the fact that a private individual's research funding is the primary driver of the world's most advanced stratospheric intervention research program is itself a governance problem that no one has solved. Effect 3. The moral hazard. The third problem is the one that makes many climate scientists most uncomfortable, not as a scientific question, but as a human one. If governments and corporations believe that stratospheric aerosol injection can serve as a temperature backstop, a safety net that prevents the worst warming outcomes, does that belief reduce the urgency of emissions reduction? This is what economists call moral hazard. And in the context of climate policy, it is existential. Some of the most respected names in climate science have publicly stated that they oppose research into stratospheric aerosol injection, not because they think it cannot work, but because they believe the existence of a perceived technological fix will be used as a political excuse to avoid the harder and more necessary work of eliminating emissions. The moral hazard concern is not theoretical. It has already appeared in policy discussions in at least 3 G20 countries, where officials have referenced geoengineering research as evidence that emergency decarbonization timelines are not as urgent as scientists claim. The scientists working on stratospheric aerosol injection are not reckless. They are not playing God without concern for the consequences. The researchers at Harvard's ESCOPEX program are among the most cautious voices in this debate, publishing not just the potential benefits, but the risks, the governance gaps, the termination shock problem, the moral hazard concern. Bill Gates is not funding a plan to unilaterally block the sun. He is funding research into whether it could be done responsibly. And the honest answer that research keeps producing is only under conditions that do not currently exist. The surprising conclusion is not that the science is alarming. The surprising conclusion is that the science is ready, and the world is not. AI climate modeling has given researchers the tools to plan stratospheric injection scenarios at a regional resolution that makes responsible deployment theoretically possible for the first time. The engineering is understood. The atmospheric chemistry is modeled. The particle sizes, injection altitudes, and dispersal strategies that minimize harmful regional effects are being mapped with increasing precision. What does not exist, and what no amount of AI modeling can create, is the governance framework that would allow this to happen without one country's solution becoming another country's catastrophe. No treaty, no international body, no agreed definition of what counts as an acceptable regional side effect, no termination protocol, no compensation mechanism for nations whose monsoons are weakened or whose harvests fail as a consequence of an intervention they did not choose. The technology to cool the planet now exists in a form that is deployable within years, not decades. The civilization capable of deciding wisely whether to use it does not. Next week, China just moved a river. 400 million people live downstream. We looked at what happens to them, and the answer involves every problem this series has covered, happening simultaneously in the most consequential river system on Earth. Subscribe. That one took the longest to research.